Okay, our last example, and I just love putting these little tidbits in, which is I can't even remember trig from school. I can't remember really enjoying it. I can't remember going, oh, I don't understand it. Really didn't stick out. And as I've started teaching it over the last few years, I've enjoyed it a bit more and more. I don't know, there's something about putting it on the Cartesian plane, working with triangles, that feels quite cool. So hopefully some of you at least feel the same way, where we can get into it. Some of you are probably smirking at me. Maybe best that I can just say this safely over the video. Anyway, so here we are. Sine theta, we know that we're gonna need a Cartesian plane. We know that's gonna be our starting point. So let's draw that in. We know it doesn't have to be perfectly to scale, but some scale helps. Our cast diagram helps. Cast, C-A-S-T. Our quadrants might be useful as well. We know this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. I think it's worthwhile writing the cast in for yourself, just so it's there on your diagram, ready to go. Just small in the corner. You could always just draw yourself another one here that goes cast for reference. But hey, that's a little bit out the way, but it's there accessible in the same diagram, I think. So here we go. Sine theta equals minus 3 over 5, and theta is between 0 and 270. Ooh. In the previous one, we talked about these angles, and let's throw this in here. This is 0 degrees. We haven't gone anywhere yet from the positive. As we go around, we've gone 90 degrees. You can see the 270 from the previous question. 180 to 270 up to this is now 360. And so it goes round and round and round. But starting here at the positive x-axis, we've gone round to, that makes sense. There's a 90 degree, right? Okay, so it's between 0 and 270. So it's between 0 and 270. It must be in this quadrant 1, 2, or 3. Definitely not in quadrant 4. So we can rule this out. I'm going to just do this like this to go not in this quadrant. I'm going to put a nice big cross for us, not there. Sine theta, they tell us, sine theta is negative 3 over 5. It's negative 3 over 5. There's our hint. Where is sine negative? Let's go around starting in quadrant 1. Definitely not here. All functions are positive here, all trigonometric functions. And so sine theta is negative 3 over 5. It doesn't make sense that it can be here because they're all positive. Okay, then we move into the second quadrant. So I'm going to put a cross here. It's not here because all are positive. Second quadrant. There's one trig function, just one that's positive here. The S means that sine is positive. Is sine given to us as positive? No, you tell me. So it's definitely not there. Left with one, I feel like I'm playing noughts and crosses. And we're left with this quadrant here, quadrant 3. Okay, quadrant 3. There's only one trig function that's positive here, tan. Tan's positive, so sine must be negative, and this is between 0 and 270. So I'm going to put a little tick over here to say we're working down here. Okay, sine theta is negative 3 over 5. Now, which one was x, y, and r? Well, sine theta, we know, is opposite over hypotenuse. Y over r. Remember, if we just had a little sketch here to go, there we draw a little triangle. There's our theta, opposite, hypotenuse, adjacent. So sine is y over r. R is always positive. R is this distance away from the origin. So R must be positive, which means this x is negative 3. So we can draw it over here and say, there it is. It's got an x value. We don't know. It hasn't been given to us. Our y is negative 3. And if we turn this into a nice right angle triangle, remember always from the x-axis, then we've got that our r value is 5. And so far that things are fitting in nicely. The y value must be negative. It's down here. Minus 3 over 5. Cool. Things are looking good. So we've got our angle, and our angle is theta. We don't know what it is. We just know that going from the positive x-axis round, this is theta. Cool. So there's theta. There's all the information we've been given. And when we can eventually do it, we're going to try and find out what that is. So we're going to need to find out what x, y, and r are. Well, we've got y and r, so we just need to find out what x is. Well, we know from Pythagoras, x squared plus y squared equals r squared. And if we have our wits about us, we can also see that this is a 3, 4, 5 Pythagorean triple. So x equals, now let's be careful, let's catch it straight away. Is x positive or negative? Must be negative, so it's going to be negative 4. And I'm going to write negative 4. I'm not even going to have a positive 4 written anywhere in my diagram, because we made that mistake once before. Okay, so we've got x, we've got y, and we've got r. I actually think it might be worthwhile writing r equals 5, and maybe over here we can even say this is our x value, this is our y, just so we can see it quite quickly. Okay, so we just got the last bit to do, and that is determine this stuff here. 2 sine theta plus cos theta. Well, that's 2 times sine theta. Well, sine theta was already given to us, so there's nothing really to do. Let's just put it in. Minus 3 over 5. Of course, you could think, oh, it was y over r, that's y. No, they've given to us here. Okay, plus cos theta. Cos theta is x over r. X value, you said, was minus 4. This is 5. Okay, so 2 times this is minus 6 over 5 plus, well, the plus and the minus become a minus. And of course, I'm doing all of this, but it might have just been worthwhile to plug this into your calculator, and to get minus 10 over 5 gives us minus 2. But I'm serious, we could have written this bit here. It might say without a calculator, doesn't matter, this is the bit that's important. Plug it into our calculator and we get minus 2. So we should be good to go. Hopefully a little bit more comfortable now with what's happening. What does this cast diagram mean? These x, y's, and r's. These 4 examples have taken us through quite nicely that. So good luck here. The exercises to do. I've written on the website which one you need to do from classroom mathematics, because you don't need to do all of these. Some of these are definitely optional, but these 3 are the starting point that we're going to do. Have fun.